Hello, my name is Dr. Danny Caputi, and I am here from the Halo Lab with the P.e.a.c.e Inc. team, and here to show you today just our latest version of the main front end that we are using and would like to deploy to the Substrate blockchain as as kind of a first step in low-hanging fruit and what we would like to eventually do with this, which is explained in our latest press release. So what you're looking at here is basically we have 4 non-random event detectors. This can also run with 8 of them. And then, so those are basically electron tunneling devices that sample quantum information and detect subtle time dilations. Which is subtly affected by their environment, including the people that are looking at them. And so what we're looking at here is basically the processed version of that. So there's some algorithms going on in the back that basically take these and turn it into usable data, which we can use for machine learning, as we've done in the X Prize, weather prediction, and really an infinite amount of applications, which again, that's called coherent sampling, that process that turns it into usable data. So right here, what we're looking at is a language oracle database from the corpus of contemporary American English. And so every second it is pulling up a new word based on this quantum data that's undergoing our coherent sampling. And these colors that you see are also independently controlled by their own data streams that we pull from our non-random event detectors. And so if you look on the right, you'll see Z-score trends. So this envelope that you see increases with the square root of the sample size. That is what we call the envelope of chance. So when it goes outside of that, then we are at a less than 5% probability of getting that many ones or that many zeros produced in a given interval. And a part of coherent sampling is once the z-scores reach certain thresholds, typically in a 1-minute sliding window. So actually, if I click on zoom here, we can see just the last minute of data and what these different, each gray line here is a different device. So we have 4 of them running in this case. And then this pink line is a kind of an aggregate of all of these using our QByte processing algorithm. And so in certain cases, we'll select certain z-score thresholds that are known mathematical constants like pi and e to trigger certain events such as changes in colors in all of these nodes you see here, and or rotation. You just saw a rotation there. Now we can rotate this manually, but this also auto-rotates. It also rotates on its own. So here I'm clicking and dragging just to show that you can flip this around and interact with this. This is a 3-dimensional graphic on the left. And down below here, you see this is the coherence of the colors. So that's separate from the actual z-score of the 1s and 0s because there's a different algorithm that selects the colors. But when you would see as in this case, like a lot of green here, or if this was all ended up being closer to one color, you would end up seeing a big spike in this lower graph, as we often see when people come around and meditate. This display that you're looking at here is a model, a simulation of a physical device that my research partner invented about 7 years ago and has taken to many events for display. World's Fair Nano, Maker Faire, Burning Man Pre-Compression, and several music festivals, and several awards for this installation has been won. And so this is just a simulation of that, but we can actually change to prototypes of other designs that we have. If I click on the View button, so this is a quadratic array processor, which is talked about in one of our white papers on our website. And this is a hypercube. And so you can see I can click and drag and rotate this, and it also will auto-rotate on its own. And it's in the middle of a rotation right now. And then we have a sphere, which again auto-rotates, and we can rotate this itself. And finally, we have a pyramid. And again, think of this as an enhanced clock. So this can be just like any other clock on your wall, but you're also seeing the subtle effects of time dilation represented in this visual data. And thank you for watching.